this is Kasturi Day. Today I've come to continue with the discussion of this force and pressure chapter according to ICSE syllabus class 8. Okay, so I'll start today with liquid pressure. Okay, so we know that solid exerts pressure. Okay, it exerts pressure on the surface due to its own weight. Because of its own weight, it exerts pressure. Liquid also exert pressure as same way as the solids on the container in which they are kept. Okay. Now a solid exerts pressure only at its bottom, on the surface at its bottom. Okay. A liquid exerts pressure in all directions, not only at its bottom but also in the sideways also. So it exerts pressure in all directions. Okay. Now we come to the factors which affect the liquid pressure. First is the height of the liquid column. The liquid pressure increases with the increase in height of the liquid column above the point. What happens if we take a test tube whose both sides are open? Okay, in the one end of the tube we attach a balloon. Okay, deflated balloon. Then we pour some water in the tube. Okay, from one end which is open, from one end we pour some water. We see that the balloon which is attached in the other end is inflated. Okay, now we pour some more water to increase the water column in the tube. We will see that the balloon inflates more. So this shows that when the height of the liquid column or water column is increased, then the liquid pressure also increases. This balloon inflates because of the liquid pressure. So that liquid pressure also increases. The density of the liquid, the another factor which affects the liquid pressure is the density of the liquid. See, again we take a test tube, rather two test tubes whose both the ends are open, and in both the tubes we attach a deflated balloon. Now in one of the tube we pour some water, and in the other tube we pour a sugar solution, concentrated sugar solution. So that will be more denser than water. So what we see, that in which the water is there, the tube in which the water is there, the balloon is inflated to some extent. But in the tube which has more sugar solution, that inflates more. So this shows that it depends the liquid pressure, and this inflation is due to the liquid pressure. Okay. So where this shows that the balloon, the balloon inflates more in case of denser liquid. Okay, so the density of the liquid is a factor which affects liquid pressure. Okay, liquid pressure increases with the density of the increased density. Okay. Now the pressure is directly proportional to the acceleration due to gravity. The liquid pressure increases with the increase in the acceleration due to gravity. Okay, where there is more gravitational force, the liquid pressure is more. It is independent of the area of cross section. Okay, so what happens if we take different cross sectional area, different types of shapes of vessels in which containers in which we keep some liquid, we'll see the height they maintain the same. Okay, so the pressure in which the liquid is kept, the pressure will be equal. Okay, so it is independent of the cross sectional area. It's important thing to note that even gases exert pressure in all directions. So the pressure exerted by the fluids, gas is a fluid, liquid is also a fluid. So the pressure exerted by the fluids on the sides of the container containing vessel is known as lateral pressure. So with the pressure which the fluids exert on the sideways of the containing vessel, that is known as lateral pressure. Okay. Now we have come to Pascal's law. Okay, it states that when pressure is applied to any part of an enclosed liquid, when a liquid is enclosed in a vessel, and if pressure is applied to any part of the enclosed liquid, it is transmitted equally in all directions. So the pressure which has been applied to any part of the enclosed liquid, that is transmitted equally in all directions with undiminished force and acts at right angles to the surface of the vessel, and it acts as right angles to the surface of the vessel. Okay, normal. Okay, so next we come to the consequences of pressure in the liquids. Okay, pressure increases with depth. We have I've told you that the height depends, the liquid pressure depends on the height of the liquid column. So it where the depth increases, that is height of the liquid column increases, the pressure also increases. It has been found that when deep sea fishes are brought up to the surface, their bodies burst. Okay, so what happens when when fishes are inside the water, there is some liquid pressure which presses the body. Okay, that pressure is more than the pressure of their body, that is fish's body. But when they are taken outside the water, taken to the surface, their body pressure increases than the outside pressure, so their body bursts. Then deep sea divers have to wear specially designed units, as otherwise the huge pressure of water will crush their bodies. Same thing, they need to wear, these divers, deep sea divers, they need to wear some specially designed suits. Okay, they need to wear it before getting inside the water, because otherwise the liquid pressure is so much that would crush their bodies. Okay, so they need to wear these suits. The hulls of the submarines are specially strengthened to bear the huge pressure of the sea water. The walls of the dams are specially thickened from the base so as to withstand huge pressure. The dam's walls, especially at the base, they have to be very thick so that they can withstand the huge pressure of the liquid below. Next we come to atmosphere. Now, atmosphere, our earth is surrounded by an envelope of air which is commonly known as atmosphere. Okay, it is found that the height of atmosphere is approximately 300 kilometers. Okay, then since air is kind of matter, it exerts force or weight on the earth's surface, thrust or weight on the earth's surface, and the objects on it, on or around it. Okay, any object which is on the earth's surface or around the earth's surface, they can experience this air pressure. Okay, because it's a kind of matter. So the force exerted by atmosphere per unit area on the surface of the earth is known as atmospheric pressure. Its value is 10 to the power 5 pascals. Okay. At sea level on Earth's surface, the atmospheric pressure is 76 centimeter or 760 millimeter of mercury column, or you can say 1.013 into 10 to the power 5 pascals. Okay, or rather you can say 10 to the power 5 pascal. 1.013 is approximately 1. Then this pressure decreases with the increasing altitude. When we go up the earth's surface above the sea level, when we go up the sea level, what happens? This air pressure decreases. So as we go higher above the earth's surface, the air pressure decreases. Okay, due to the high atmospheric pressure, every 1 meter square of the surface of any object experiences a force of 10 to the power 5 Newton, or 10 to the power 4 kgf, or 10 tons approximately of force. Okay. Next is that, but we do not experience so much force we experience, but we do not feel that force. Okay, if we assume that the surface area of an adult is 2 meters square, the force experienced is 2 into 10 to the power 5 Newton or 20 tons, because our blood pressure contains dissolved oxygen which is at pressure of more than 2 into 10 to the power 5 pascals. Okay, so we have blood inside it, and that exerts a pressure, because there the oxygen is dissolved in it, and that exerts a pressure, blood pressure you can say, that is equal to 2 into 10 to the power 5 pascals, which is more than that of the outside pressure. So we do not feel that pressure. This pressure in the blood is commonly known as blood pressure, which counterbalances the atmospheric pressure. The atmospheric pressure is measured by a barometer. It was first constructed by Torricelli in 1643. This barometer, simple barometer, was constructed by Torricelli, after whom the vacuum above the column of the mercury inside the barometer is known as Torricellian vacuum. Okay. Now, different barometers are used, like simple barometer, Fortin's barometer, aneroid barometer. Okay, these three are mainly common in this different types of barometers which are used to measure the atmospheric pressure. Okay, so I'll continue with the the remaining of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. And if you have any other questions regarding the other chapters or this chapter, please do write it down. Okay, write in the comment box. Okay, and hope you are liking the videos, and if you are liking it, please do press the like button and share with your friends so that they can also be benefited from these videos. And if you're a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.